Okay, so this is the review for the Integrated Math 3 Unit 6 test. I am not going to do every single problem on the review. I'm going to go ahead and pick and choose some of the ones that I feel you guys need more help with. Okay, so let's get started. Number one, the annual sales for a company are 950,000 and are increasing at a rate of 5% per year. Write a function that expresses the annual sales after n years. Then find the annual sales after 4 years. Okay, so what I'm going to use here is this formula, which is used for interest. So V here means interest and P is the principal. But I'm going to adjust it to make it fit this situation, right, where we have annual sales for a company and they're increasing by the same percentage each year. Okay, so you have seen this formula before in this form, where we write f of x or f of t or f of n equals a times 1 plus r to the power of t or to the power of n, which is the same thing. It's the same idea. We use usually this one for investments, right, something that grows at a certain interest rate. And this one for all other situations that are growing or decreasing by a percentage. Okay, so either one, it's the same thing. It's the same idea for both of them. So then let's go ahead and plug in some numbers. Let's read the problem. It says the annual sales for a company are 950,000. That's this number, right? A or P as it was in the other formula, which is the initial amount. So A is $950,000. Also, it says that it's increasing at a rate of 5% per year. That's R. R is 5%. But we never leave it as a percent. We turn it into a decimal, which is 0.05, 5 hundredths. And then it says write a function that expresses the annual sales after n years. So let's go ahead and write the function now. It's going to look like this. F of t. And I'm using t for time, although in the problem it says n for time. But I'm going to go ahead and use t. It's the common custom to use t for the number, the time in years. So f of t equals a, which is 950,000, times 1 plus r. So if you think about that, you can use mental math and say that's 1 plus 0.05, so 1.05 to the power of t. And then you can answer the question by plugging in what they tell you. It says find the annual sales after 4 years. So plug in 4 for t to solve it. So that's what I'm going to do now. I'm going to plug in 4 for t, which basically means that I'm finding what f of 4 is. 950,000 times 1.05 to the power of 4. And at that point, you basically use your calculator. You would do this part first, 1.05 to the 4th power, and then multiply times 950,000 to make sure you do your calculation correctly. So according to my calculator, it looks like I'm getting f of 4 is, it's giving me $115,473. Oops, 73. And 9 cents. That's what I get after 4 years. Alright, let's move on to number 2. And by the way, for the interest of time, I am going to go a little bit fast on these problems just so I can keep the video shorter than the ones that I've been putting up lately. So it should still be okay. Just remember that you can always pause it whenever you feel like I'm moving too fast and you need to slow down or rewind, okay? But I am going to be going a little bit faster on these problems just so I can make the video a little bit shorter. Okay, here we go. Number 2, John invested 20,000 into a plan right away. I can see that A is 20,000. That's how much he invested. A or P, that's the principal, right? That earns 6.2% interest, that's R, 6.2%, which means 0.062, right, in decimal form. So let's write our problem. It's going to be V of t equals P, or A, 20,000. Now I'm using V to represent the investment. In this problem, you could use f of x or f of t if you want. Times 1 plus r, which is 0.062, to the power of t. There's my function. I'm going to simplify that by adding the parentheses there. 20,000 times 1.062 to the power of t. Now I'm going to go ahead and plug in 12 because they're asking me how much will the account have in 12 years. And at that point, it's calculator work once again, right? You would do this part first and then multiply times 20,000. So I'm going to punch this into the calculator. And the calculator says that I'm getting V of t is equal to $41,164.63. That is the amount in his investment. Alright, number 3, graph the following function y equals negative 1/2 times 4 to the power of x minus 2 plus 3. State the domain, the range, the asymptote, and the end behavior. Okay, I am going to start. I'm probably not going to do the entire problem all the way to the end. I know you guys know how to graph, but I'll just show you the basic steps of how to get there. Okay, so I'm going to start with the parent function table, and by finding b, h, a, and k, as we always do. So if you look at your function, you should be able to find b by this point so easily. It's 4. Right? It's the base of your exponent. H is always up here next to the x. It's always x minus h, so that means that h is 2. A is the number in front of b, so negative 1/2. And k is always out there at the end by itself, which is 3. Using those values, we're going to transform our parent function, okay? Now you got to make sure you remember this is an exponential, not a logarithmic, so you got to make sure you use the correct values here as your starting points, okay? For an exponential, we're going to use 0, 1, 2, and 1, b squared, which in this case is 4 and 16. 16 is probably going to be too big to graph, but let's put it in there anyway. And then we're going to transform that into a new one using h, a, and k. Remember, we don't use b anymore. We already used it to start our table. So h, a, and k, that means that we're going to add 2 to the x values, right, h. We're going to multiply the y values times negative 1/2 and then add 3. We're going to do all of those things. So let's start with the x values, adding 2. Add 2 to all of these, which is going to make them 2, 3, and 4. For the y values, I am going to multiply times negative 1/2 and then add 3. Right? Times negative 1/2 plus 3. Times negative 1/2 plus 3, like this. Times negative 1/2 plus 3. That's a 2. And I got to do that to all of these. Okay? So using a little bit of mental math, I can see that 1 times negative 1/2 is going to be negative 1/2 plus 3 is going to be 2 and 1/2, right? 2.5. And it will be easier for us to graph if we leave it in decimal, so I'm going to leave it in decimal. The next one is going to be 4 times negative 1/2 plus 3. 4 times negative 1/2 is negative 2. Negative 2 plus 3 is 1. 16 times negative 1/2 plus 3. 16 times negative 1/2 is negative 8. Negative 8 plus 3 is negative 5. Okay, in order to graph it, you also need to know what the asymptote is going to be. And since this is an exponential function, it's going to be a horizontal asymptote, y equals k. Okay, in this case, k is 3, so it's y equals 3. So there's a horizontal asymptote at y equals 3. This is the table of values you're going to plot. Use that, and then you should be able to graph the graph yourself. Okay. The last thing you need to find is the domain, the range, and the end behavior. So let's do that. We don't really need the graph, although it does help to have it handy. Domain, range, and end behavior. But we could figure it out. So domain. Exponential functions have a domain of all real numbers, always, no matter what. So you're going to have negative infinity is less than x is less than positive infinity. Which basically means that x could be anything you want it to be. You could plug in whatever you want into this function. The range is limited by the asymptote. right? Since the asymptote is y equals 3, that means that the graph cannot pass that point, okay? A is negative. You see that here? That means that this graph is pointing down. So y equals 3 is the asymptote. All the values of y are going to be below that point. It's going to be y is less than 3 because A is negative. That means the graph is pointing down. And finally, the end behavior. The end behavior is also determined by which way the graph is going. As x approaches something, y approaches something, right? That's how we start our end behavior. So on the left side, if we could picture this graph, on the left side, the graph will be approaching the asymptote. It probably is easier if you're looking at the graph, you could see it, but you could also see it from here from the table, right? On the left side, look, as x is getting smaller and smaller, these numbers are also getting smaller and smaller, but there's a limit as to how far they can get. -5, 1, 2.5, the limit is going to be 3, right? So as x goes to negative infinity, that means to the left, y approaches 3. On the right side, as x goes to positive infinity, y will be going down because a is negative, right? So y will be approaching negative infinity. And there you go. You got your table, which you can use to graph, your asymptote, your domain, your range, your end behavior. All right, I'm not going to do number 4 for you guys or number 5. I think you guys can handle that on your own. The only thing I want to remind you guys of is that these are exponential. Look at the difference between those and the logarithmic functions that we're going to see later. Exponential functions, your table is 0, 1, 2, 1, b squared. That's what you start with, and then do everything the same way. Do the transformations the same way. Find b, h, a, and k. Alright, let's move on to number 6. It says in 2010, the population of a town was 35,500. The population has been decreasing by a rate of 3% every year. Write a function f of n that expresses the town's population after n years. What is the expected population in the year 2018 to the nearest 100? So they want us to write a function, f of n, that is going to look like this. Right? Anytime you have a percent change, you're going to use this formula right here. If it's increasing by a certain percent, then r is positive. But if it's decreasing by a certain percent, then r is going to be negative, in which case it would not be 1 plus a number, it'll be 1 minus a number, right? So let's see. In this case, the population of the town started at 35,500. That's A. That's the initial population, initial amount. R is 3%, but change it to a decimal, 0.03, but also it's been decreasing, which makes it negative. And once you think of it that way, it's much easier to solve, because all you got to do is just plug in those numbers. So it's going to be f of n equals 35,500 times 1 minus 0.03, 0.97 to the n power. And then the question is, what is the expected population in the year 2018? Since it started in 2010, right, from 2010 to 2018, that's 8 years later, right? So plug in 8 right there. F of n equals 35,500 times 0.97 to the 8th power. And at that point, again, it's calculator work. Go ahead and punch that into a calculator to figure out what the population is. So my calculator says 27,822, but it says round to the nearest 100, right? So it's going to be 27,800. 27,800 people left in this town after 8 years. Right, I'm also going to let you guys handle number 7 on your own. The only thing I will tell you is that you're going to use the same formula I just used in the last problem. F of n, or f of x, or f of t equals a times 1 plus r to the power of t. And in this case, I hope you guys can see that a is 38,700 and r is 16%, but it's negative because it's depreciating. So you're going to put in negative 0.16. So when you put it in here, you're going to get actually 0.84 to the power of t. Okay? And then you guys can handle pretty much the end of it. Alright, number 8, graph the following function. It's just like the ones we just graphed before, guys. The base is e, so I'm going to let you guys handle this one also. Just remember that since it's an exponential function, it's still not a logarithmic function. You're still using the same table. 1, 0, 1, 2, and 1 b squared. In this case, b is e. So e and e squared is where you start. And then you do everything the same way. Okay? Same thing for number 9. The base is still e. A is -4/3. Okay, so that's not the base. The base is e in this case. So you're going to use the exact same table as this one right here. Alright, number 10. KC made a $4,000 investment in an account that earns 5.5% interest compounded continuously. Okay, keyword right here. Compounded continuously. That means that I'm going to use this formula for investments. V of t equals P times e to the RT power. Okay, where P stands for the principal, R for the rate, T for the time, and E is the natural base, right? 2.7 something. So we're going to plug in all the values that they have here for us. The investment is 4,000, so that's P. 4,000. The account earns 5.5%, so R is 5.5%, which we're going to change to decimal form, 0.055. And the questions, there's 2 questions. So for the first one, t is 10 is what they want us to plug in. So let's go ahead and plug that in. It's going to look like this. V of 10, because I'm plugging in 10, is equal to P, which is 4,000, times E to the power of R, which is 0.055, times T, which is 10. That's what you have. And again, at that point, it's just calculator work. What you should start with is with the exponent to simplify it. So it's 4,000 times e to the 0.55, because I multiply these two numbers times each other. Okay, and then what you're going to do is this part and then times 4,000, and you're done. You'll find the amount after 10 years. So calculator at this point. So my calculator says 6933. V of 10, or the value of the investment after 10 years, is $6,933.01. Okay, the next part of the question says, when will the investment double? So we answered this question. This is a separate question. When will the investment double? So what you do in that case, let me erase all this. Let me use this side. What we do in this case is that we don't know what t is. Right? We don't know that t is 10 like in the last problem. We don't know what t is. We know everything else. We also know what the final value of the investment is what we want. If it starts with 4,000 and we want it to double, that means that they want us to put in 8,000 right here. So that's what I'm going to do. I'm going to plug in 8,000 for V of t equals 4,000 times e to the 0.055 t. And we don't know what t is. We're going to solve for t. So the way I'm going to solve that is with a logarithm. The first thing I'm going to do is divide by 4,000 to cancel it. Divide by 4,000 on this side as well. So that's 2 equals e to the 0.055t. And now what I'm going to do is take the log of both sides. Since the base is e, I'm going to take the natural log of both sides. So natural log of 2 equals natural log of e to the 0.055t. And then I'm going to use the power property of logarithms to bring this down to the front. So I'm going to erase this old work over here so I can continue working here. So what I have now is natural log of 2 equals 0.55t natural log of e. And natural log of e cancels, right? That's one of those properties. That's 1. So all I have is 0.55t equals ln of 2. So what I'm going to do is divide by 0.55 to isolate the t. And there it is. T equals whatever that is. Punch it into the calculator. Now my calculator is giving me a weird number, but I think I just saw what the mistake is. I hope you guys caught it before I did. What is the number here? 0.055. What is the number here? 0.55. That's a big difference between those two numbers, right? So this is where I messed up. It should be 0.055, 0.055, 0.055. So this should give me the correct answer if I just fix that. So I'm going to fix this. It's 0.055. So I'm going to divide by 0.055, 0.055. There you go. That should give me the correct answer, which is 12.6 years. The account will double in 12.6 years. Alright, I am not going to do 11 or 12 for you guys. You guys can watch the other video that I posted before, specifically on compound interest. The only thing I will tell you is that for 11 you have to use this formula, which I'm going to write right now. V of t is equal to p times 1 plus r over n to the power of nt, which in which n represents the amount of times that the account gets compounded per year. So semi-annually means 2. Quarterly means 4. But you're going to use the same formula for both of these. Okay? So I'll let you guys handle those on your own. Alright, 13. Write the following equations in logarithmic form. Okay, these are going to be fast. Let's look at A. 4 to the third equals 64. What you do to change this to logarithmic form is first notice the base. The base is 4. So you're going to write log base 4 of not 3 but 64, right? You go to the other side. Log base 4 of 64 equals 3. That's how simple that is. Look at B. You have 2 to the negative 3 equals 1 over 8. Same thing. Notice the base first. The base is 2, so your log should have a base of 2. Log base 2 of not negative 3, you go to the other side, which is 1 over 8, equals negative 3. Now for C, e to the 0 power equals 1. The base is e, so you're going to have a log with the base e. The log with the base e is called a natural log, so we're going to use ln, natural log, of 1 equals 0, which is true. And actually it's true for any logarithm. Any log of 1, doesn't matter what the base is also always going to be 0. Okay, 14, same idea, but you're going the other way. So there's only 2 of them here. Log base 3 of 81 equals 4, that's A. Let's do that one first. Log base 3 of 81 equals 4. I'm going to exponential form, so once again notice the base first. Base is 3, so you have an exponent, a power with base 3. Your exponent is not 81 but 4. Go to the other side to get it. Equals 81. See that? And then B. The base of this one is not written there, which means what? It's 10. This is the common logarithm. If the base is not written, it's 10. Unless it says ln, which means a natural log, which means that the base is e. So in this one, the base is 10. So 10 to the power of 4 equals 10,000. There you go. Alright, 15. Graph the function f of x equals log base 3 of x plus 2 minus 1. State the domain, the range, the asymptote, and the end behavior. So I'm going to start, first of all, by finding b, h, a, and k. B is the base of the logarithm here, so that's 3. H is next to x, right here in the parentheses, x minus h. That means that h is negative 2. A is in front of the logarithm, which there's nothing there, so A is 1. And K is here at the end, which is negative 1. I'm pretty sure all of you guys can find those values easily by looking at the function. Then what you need to do is figure out what your initial table is going to be. And this is where you got to remember, this is a logarithmic table, not an exponential table. So it's the inverse. You're going to flip these values the way they usually do them. 0, 1, 2 is for the y values, and 1b squared is for the x values. In this case, b is 3, so 1, 3, 9. But then everything else after this works out exactly the same as before, right? We don't use b for the transformation. We only use h, a, and k. Everything else is the same. I'll let you guys finish that. What I do want to mention though is the domain, the range, the asymptote, and the end behavior. The asymptote, to start with, is a vertical asymptote, right? For an exponential function, like the ones we did before, it's a horizontal asymptote. But for a logarithmic function, it's a vertical asymptote, which means that it looks like this: x equals h, not k, h. So that's the difference between the exponential and the logarithmic. The exponential had y equals k, this one has x equals h, which means x equals, in this case, -2. That's your asymptote, a vertical asymptote that passes through -2. The domain and the range are also different. They're kind of flipped their roles. The range in this case is limited by the asymptote, right? So you just got to figure out the asymptote is the value that the graph cannot cross. Is it going towards the right or towards the left? These are going to go to the right, so x is greater than -2. And you could probably see that better by actually looking at the graph. The domain is did I just flip that? Yes, I did. Yes, I did. I am telling you guys the wrong information. The domain is the one that is limited. I was wondering why I was writing x if it's the range. Right? The domain is limited only to the right of the asymptote. The range is the one that is going to be unlimited, meaning that you could put in whatever you want. So y such that -infinity is less than y is less than +infinity. Right? All real numbers for y. And finally, the end behavior. It's helpful if I actually see the graph, although I know what it looks like. I have an idea of what this graph is going to look like. There's going to be a vertical asymptote, and the graph is going to increase like that. Okay, or else if A is negative, then it's going to go like that. Right? There's possibilities of what it could be. But this one is A is positive, so it's increasing like that, and the base is a big number, so I know it looks like this. And you guys can confirm that using your graph. So if I know it looks like that, I know that as x approaches, it does not go to -infinity. Usually we put -infinity there, but this one does not, right? Because there's a limit as to how far it can go. It can only reach whatever the asymptote is, which is -2. So as x approaches -2, y approaches -infinity, which means that as x gets closer and closer to the asymptote, y is decreasing more and more. On the other side, on the right side, as x goes to +infinity, to the right forever, y goes to +infinity as well. It goes up forever. And there it is. The only thing you got to remember of this one is the table that you start with. That's the important thing here, and the asymptote. It's not y equals k, it's x equals h, because it's a logarithmic function, not an exponential function. I'll let you guys work on 16 and 17 on your own. The only thing you got to remember, once again, and I will give you right now, is that the table is 1bb squared on the x values. In this case, b is e, so 1e squared and 0, 1, 2. And the asymptote, remember, is x equals h, not y equals k. Same thing for number 17 over here. You start with this same idea here, and you should be able to graph it. 18, write the expression as a single log. Evaluate if possible. That should be pretty simple by this point. I'm adding two logarithms that have the same base. So what I'm going to do first is bring this 2 up to become an exponent. So it's going to be log base 3 of 3 squared plus log base 3 of 9. I'm going to put them together. Log base 3 of, when you're trying to add two logarithms that have the same base, that means you multiply their inputs here. So that this is 9 and this is 9, so it's log base 3 of 81. Right? Once again, I'll repeat that. This is 9, this is 9. I want to put them together by addition, means that I multiply these numbers. 9 times 9 is 81. And then I'm going to simplify that because I know 81 has a base of 3. It's a power of 3. It's 3 to the 4th power. And actually this simplifies all the way down to just 4 because I'm going to bring that 4 down and this cancels. There's your answer. Alright, for b, what I have is log base 4 of x minus 5 log base 4 of y. I'm going to do the same thing. First thing I'm going to do is bring the 5 up. I can't subtract them or add them until this is out of the way. Okay, so I'm going to do log base 4 of x minus log base 4 of y to the 5th power. And now the subtraction here means division of the inputs. So I'm going to put them together with the same base, log base 4 of x over y to the 5th. Notice this one goes in the numerator, this one goes in the denominator. And that's it. It's asking you to put it as a single logarithm. So it's done. 19, expand the logarithm. What you're going to do here is the opposite of what we just did in the last one. Okay, I notice a fraction here, I notice division, that means subtraction. So I'm going to write two logarithms, one for the numerator, one for the denominator. It's going to look like this. Log base 2 of 4 times the cube root of a minus log base 2 of b squared. So why am I using minus? Because these are being divided, right? Dividing the inputs means subtracting the logarithms, keeping the same base, base 2. Next, what I see is that here I have a product. There's two factors here, 4 and cube root of a, that are being multiplied times each other. So that, if I'm trying to expand it, that means that there's two logarithms here that are being added. So what I'm going to do now is separate them. Log base 2 of 4 plus log base 2 of cube root of a minus log base 2 of b squared. That's what I have now. I'm going to simplify this. Log base 2 of 4 is just 2. Think about it. 2 to the what power is 4? 2. This is just 2. This one right here, cube root of a, is a to the 1/3 power, right? Remember the rules of radical rational exponents? That's a to the 1/3. And this one over here, I can already bring the 2 down. 2 log base 2 of b. So in this one, I'm going to bring the 1/3 down. 2 plus 1/3 log base 2 of a minus 2 log base 2 of b. There is your final answer. All right, let's look at b. B is much easier. Natural log of 2x squared y. I'm going to break those up. There's three things being multiplied here. 2, x squared, and y. So I'm going to write it as natural log of 2 plus natural log of x squared plus natural log of y. And the only thing left to do here is to bring the 2 down. So natural log of 2 plus 2 natural log of x plus natural log of y. And that's it for that one. Alright, number 21. Solve the following equations. Give both the exact answer and the approximate solution rounded to 3 decimal places. What I'm going to do for these problems is I am going to solve them all using base 10. And then once I get to these over here, I'm going to solve them all using whatever the base of the equation is. Okay, so you guys can see the difference between the two. But I'm not going to solve each problem in two different ways. Just so you guys see that there's multiple ways to solve it. You don't have to choose the same base every single time. Okay, so for A, B, and C, I'm going to use base 10 for all of them when I take the logarithm. And some of you guys might be wondering, what are you talking about? These are exponential equations, so to solve them, we're going to have to use logs. Okay, that's the only way we're going to be able to solve them. So here we go. Let's start with A. A says 4 to the power of 2x plus 1 equals 30. I'm going to take the log of both sides. Base 10. Oops. Log of 30. So I'm using the common logarithm to solve it. The common logarithm which is base 10. So now what I'm going to do is bring this exponent down to the front. So I got 2x plus 1. Log of 4 equals log of 30. Then what I'm going to do is divide by log of 4 to get rid of it. That cancels. So it's 2x plus 1 equals log of 30 over log of 4. Then what I'm going to do is subtract 1 from both sides. So 2x equals log of 30 over log of 4 minus 1. I'm going to continue up here. So I'm going to write it again. 2x equals log of 30 over log of 4 minus 1. And finally, I'm going to divide by 2. Now, when I divide by 2, I got to divide this one by 2 and divide this one by 2, okay? So what does it mean to divide this one by 2? Just put the 2 in the denominator. So it looks like this. X equals log of 30 over 2 log of 4. That's what dividing by 2 means in that case, because it's already a fraction. Minus 1/2. There you go. That is the exact answer. Of course, there's more than one way of writing it. Like I could change the 1/2 to the same denominator as this one by multiplying times log of 4 over log of 4, so I could put them together. But it really makes no difference in what the exact answer is going to be. It says give both the exact answer and the approximate solution. So the approximate solution means punch this into a calculator to see what you get. Okay, I'm going to punch that in to see what I get. Be careful when you guys are doing the calculation in the calculator. What I suggest you guys do is do it by parts. Do this one first, then do this part, and then divide the two numbers, and then subtract 0.5 or 1/2. Right? That's what you should probably do to make sure you don't make mistakes. Okay, what do I get? Let me see. So my calculator says 0.727, 3 decimal places. There's your answer for that first one. Okay, now that I hope you got the hang of it a little bit, I'm going to go through the other ones a little bit faster. So let's see, let's start with number B, letter B. Okay, B. 6 to the negative 4x plus 1 power minus 10 equals negative 2. First thing I'm going to do is kick out the 10. It doesn't belong. Don't take the log of both sides until you get rid of everything that is around your power, okay? So that goes away. 6 to the negative 4x plus 1 equals 8. Now I'm going to take the log of both sides. Base 10 again. Negative 4x plus 1 equals log base 10 of 8. The common log of 8. Next I'm going to bring the power down. So negative 4x plus 1 times log of 6 equals log of 8. Next I'm going to get rid of the log of 6 by dividing by it. There's log of 6 over log of 6. Cancels. So I got negative 4x plus 1 equals log of 8 over log of 6. And next I'm going to isolate the x by subtracting 1 and then dividing by 4. Right? So I'm going to continue up here. So subtract 1 from both sides. Subtract 1, subtract 1. So what I have is negative 4x equals log of 8 over log of 6 minus 1. And next I'm going to divide by negative 4, which again, just like I did the last one, remember dividing by negative 4 here means put it in the denominator, and here means write it underneath the 1. So x equals log of 8 over negative 4 log of 6 plus 1/4, right? Because it's negative 1 divided by negative 4, positive 1/4. There is your exact answer. The rounded answer to 3 decimal places means punch it into a calculator. So let's see what my calculator says here. So the calculator says x equals negative 0.04. 3 decimal places, so 040. There you go. That's your approximate answer. Alright, C, 5 to the power of 2x over 3 equals 10. Once again, I'm going to solve it using the common logarithm, base 10. It's already set up. There's nothing to kick out or remove or move out of the way, so I'm just going to take the log of both sides. So it's going to be log base 10. And remember, when it's base 10, you don't have to write the base. Log base 10 of 5 to the power of 2x over 3 equals log base 10 of 10. Okay, next what I'm going to do is bring this power down here. So it's going to be 2x over 3 log of 5 equals log of 10, which is 1. Worked out very nice like that. Next, if I want to solve this, I need to get rid of the log of 5 here and the 3 and the 2, right? I want to isolate the x. So let's start with the log of 5. I'm going to divide by log of 5 to get rid of it. goes away. So what I have is 2x over 3 equals 1 over log of 5. Next, I'm going to get rid of the 2/3 by multiplying times 3/2 on both sides, and that should cover it. That's going to give me x equals 3, right? Because when you multiply 1 times 3, it's 3. Log of 5 times 2. Don't multiply the 5 times the 2, please. Do not make that mistake. 2 is going to go right here in front of log. So 2 log of 5. And there's your exact answer. The approximate answer is going to come from punching it into the calculator. So let's see what that says. Okay, the calculator says 2.146. So there you go. That's your approximate answer, and that is your exact answer. Okay, for D, E, and F, they're also exponential, but I'm going to show you guys that you don't have to use base 10 all the time. I'm going to use whatever the base is of the power. So for example, in this one, I'm going to use base 4. In this one, I'm going to use base E, and in this one, I'm going to also use base E. Okay, I'll probably keep doing the same thing for all of these. I'm going to use base E to show you guys you don't have to use base 10. You can, but sometimes it might be easier or more helpful for you guys to use the same base as the power that they have already. Okay, so here we go. Let's start with D. 4 to the power of x plus 1 plus 5 equals 3. The first step is still the same. I need to get rid of that 5, right? Whatever doesn't belong there, don't take the log yet until you kick it out. So 4 to the power of x plus 1 equals negative 2. Next, I'm going to take the log of both sides, and I'm going to use base 4, because that is the base of that power there. Log base 4 of 4 to the x plus 1 equals log base 4 of negative 2. On this side, I'm going to bring this down, and also log base 4 of 4 is going to cancel at the same time. So all that's left is x plus 1. And then on this side, I have log base 4 of negative 2. Oh, I just noticed something on this problem, and it basically allows me to just stop already. See this right here? Log base 4 of negative 2. One of the restrictions that we have for logarithms is that this number can never be negative. It can't be 0 and it can't be negative, right? So if that's not possible, then this has no solution at all, okay? This has no solution at all because this number cannot be negative, cannot be 0. So I think I'm done here. No solution. And if you look at this right here, guys, you could probably see it right at this point. 4 to the power of x plus 1 equals negative 2. There's nothing you could raise 4 to the power of something, 4 to the power of something that's going to give you a negative. Never, right? You could raise it to a positive number, to a decimal, to a negative number, but you're never going to get a negative, right? Even if you raise it to a negative number, all that's going to do is just going to make it a tiny little number, right? It's going to give you a decimal, but you're never going to get a negative. There's no solution here. Alright, let's look at E. 3 times e to the power of 2x minus 5 equals 21. The first thing I'm going to do is get rid of the 3. So let's divide everything by 3. Right? You just wanted to make it, you want to make it as simple as possible. Leave just the base and the power. That's all you need. So the 3's cancel. E to the power of 2x minus 5 equals 7. Next, I'm going to take the log of both sides, and I'm going to use the same base as this power, which is base e. So if I want to take the log of base e, that means the natural log. So natural log of e to the power of 2x minus 5 equals natural log of 7. What's going to happen here is that this is going to cancel, and this is going to come down. So it's 2x minus 5 equals natural log of 7. You're going to add 5 to both sides. Let's continue over here. So you got 2x equals natural log of 7 plus 5. And then you're going to divide by 2. X equals natural log of 7 plus 5 all over 2. That's the exact answer. To find the approximate answer, just punch that into your calculator. Let's see what it tells us. My calculator says 3.47. 3 decimal places, 473. Right, F. F is ready and should be a lot faster than all the other ones. I'm going to take the log of both sides, base e, that means natural log again. So natural log of e to the power of x equals natural log of 9. Bring the x down, cancel this, so that's just x equals ln of 9. That's the exact answer. The calculator will tell you what that is approximately. Calculator says 2.19. 2.197 actually. Okay, G, same idea. The first thing I'm going to do is subtract 4. Hoping that you guys are getting the hang of this after seeing so many times. Equals negative 3. Next, I'm going to divide by 5. E to the 3x equals negative 3/5, whatever that is. And I'm done. Right? Why? Because I got a negative on this side, and there's nothing I can raise e to. There's nothing I can put here that's going to give me a negative ever. This one has no solution as well. And just watch out for that. If you try to continue, you're going to have to take the natural log of both sides, and once you try to take the natural log of a negative number, you'll see that that's an error in your calculator. There is no solution there. Okay, finally, H. 2e to the 5x plus 1 minus 8 equals 4. Once again, I'm going to start the same. I'm going to add 8 to both sides. So 2e to the 5x plus 1 equals 12. I'm going to divide by 2. E to the 5x plus 1 equals 6. I'm going to take the natural log of both sides because the base is e. Equals natural log of 6. I'm going to bring this power down and cancel the ln of e. So it's just 5x plus 1 equals ln of 6. I'm going to continue over here. I'm going to subtract 1. So I got, continue over here, 5x equals ln of 6 minus 1. Divide by 5. X equals ln of 6 minus 1 over 5. That's the exact answer. The approximate answer is going to come from the calculator. Let's see what it says. And the calculator says x equals 0.158. There it is. Alright, 22. Identify the following functions as exponential growth, exponential decay, or neither. All you're looking for is that it's an exponential function. If it's not an exponential function, then you're going to say neither. If it is an exponential function, meaning the variable is an exponent, you're looking for the b value. If b is bigger than 1, it's growth. If b is smaller than 1, it's decay. Okay, so here we go. First one right here, there's an exponential function. Why? Because x is the exponent. B is 2. This is growth. Right? Bigger than 1 means growth. B, that's exponential because the exponent is a variable. It's x, right? B is 3. That's also growth. There's another B over here. Okay, so that must be a typo. All right, let's call this one C then, and then this one was B. Right? A, B, C, D. That makes more sense. So this one's B. E to the x minus 1. It's exponential, right? Because there's an exponent, which is a variable, and the base is e. E is a number that is bigger than 1, right? That is 2.7, so that is also growth. D, 4/3 to the power of x. That's a variable. That's an exponent. This is exponential. 4/3, don't get confused. It is a fraction, but it is bigger than 1. This is 1.333, so that's growth again. E, x squared plus 2x minus 3. That is not exponential, right? You're looking for an exponent that is a variable. The exponent here is 2. All the variables are not exponents. They're bases, so not exponential, so neither. Okay. F, 1 over 5 to the x power minus 3. That is exponential because the exponent is a variable. The base is 1/5. That's a number that is less than 1, so it's decay. F of x equals 4 times 0.35 to the x power. That's exponential. Look at the variable. It's an exponent. 0.35 is b, which is a number less than 1, so that's decay. And finally, this one is not exponential. Notice the variables are not exponents, they're bases. So this is neither. 23, write the transformation of the function f of x equals log base 5 of x with the following. Vertical compression by a factor of 2/3, translated 2 units right and 3 units up. So first figure out what all of these things mean. Vertical compression by a factor of 2/3, that's A. They're saying A is 2/3. Translate 2 units right, that's H. They're saying H is 2. And 3 units up, that's K. K is 3. Using those values and B equals 5, you can make your function. So it's going to look like this. F of x equals A, remember A is always in the front, 2/3, times the log base 5 of x minus h, which is x minus 2, plus k, which is 3. There it is. We could do the same thing for B. They want a vertical stretch by a factor of 2. A vertical stretch by a factor of 2, that is A. A is 2. They want a translation of 4 units left, that's H. H is negative 2. They want a translation of 1 unit down, that's K. K is negative 1. Negative 1. Fix that. Put those numbers in with the same base. Base is 5, right? So it's going to look like this. F of x equals A to log base 5 of x plus 2 minus 1. And that's your function. Alright, 24. Solve the following equations. Give both the exact answer and the approximate solution rounded to 3 decimal places. So the way we're going to solve these logarithmic equations is by using exponential form, right? Notice that the x is in here in the input of the logarithmic equation. So the only way to take this out of it is to turn it into exponential form. So here, let's put it in exponential form. Watch. For this first one, the base of this logarithm is 3. So what I'm going to do is set base 3 to the power of, remember how it works when you're switching from logarithmic to exponential, 3 to the power of 4 equals 3x plus 2. And 3 to the power of 4 is just 81 equals 3x plus 2. And then you subtract 2, and 81 minus 2 is 79 equals 3x. And then you divide by 3, and then you're done. X equals 79 over 3. 3 doesn't go into 79, so you can leave it like that, or you could round it to approximately 26.3. And 3 is going to keep repeating, so let's just leave it like that, 26.3. Let's do it again for part B. Again, I'm going to switch this to exponential form. The base here, remember, is e. So what I'm going to do is e to the second power equals 4x minus 7. So e squared equals 4x minus 7. What I'm going to do is square e. I'm going to add 7 first. So it's e squared plus 7 equals 4x. And then I'm going to divide by 4. So there it is. X equals e squared plus 7 over 4. That is the exact answer. If I want to do the approximate answer, I got to actually multiply, do e squared, then add 7, then divide by 4. So I'm going to do that on the calculator. And my calculator says that x is equal to 3.597. Approximately, right? This is an approximate answer. There you go. Alright, last one. Find the inverse of each function below. F of x equals 3 to the x power minus 4. Remember, the inverse involves solving for x and then isolate and then flipping the x with the y, right? So the first thing I'm going to do is change f of x to y. Then I'm going to try to isolate the x by subtracting 4 first. Basically, it's like solving an equation for x. So it's y plus 4 equals 3 to the power of x. Now, in order to solve for x here, I'm going to change this to logarithmic form, okay? So what I'm going to do, notice that the base is 3, so I'm going to change it to logarithmic form. Log base 3 of what? Think about it carefully. Log base 3 of the opposite side, right? Y plus 4 is equal to x. And that's it. Now what I got to do is just isolate flip the x with the y. So it's y equals, right? I also flipped it. Here's the x. I moved it to the left side and I changed it into y. Y equals log base 3 of x plus 4. And there it is. That's the inverse. Of course, you're going to write y as f inverse. You're not going to leave it as y. But that is the inverse. Let's try another one. B. F of x equals 4 times log base 2 of x minus 2. I'm going to start by changing this to y. And the goal is to isolate the x. This is a logarithmic, so I'm going to need exponential. What I'm going to do first is get rid of the 4. Let's divide by 4. So it's y over 4 equals log base 2 of x minus 2. Next, what I'm going to do is change this to exponential form, just like we've been doing. So here's the base, this is the exponent, and this is what you get, the result, right? So to make this in exponential form, it's going to look like this. 2 to the y over 4 equals x minus 2. See that? I'll repeat that. Here's the base, here's the exponent, here's the input, the result. 2 to the power of y minus 4 equals x minus 2. And the last thing to do is to add 2. So it's going to give me x equals, I flip the x to the left side, I always like it on the left side better. 2 to the y over 4 plus 2. And then finally flip the x with the y. So y equals 2 to the x over 4 plus 2. There is your inverse. Alright, these are the last two. F of x equals log base 10, right? If there's no base, it means base 10 of x plus 5. Start by changing this to y. Y equals log base 10 of x plus 5. Why did I choose to write the base? So I could change it to exponential form and you wouldn't be confused. Here's the base, here's the exponent, here's the result. In exponential form, this is 10 to the power of y equals x plus 5. Next, subtract 5. So x equals 10 to the power of y minus 5. And flip the x with the y, so y equals 10 to the power of x minus 5. And I haven't been doing it in the other ones, but change the y to f inverse so that we know it's the inverse. And there you go. Alright, in D, same thing. I'm going to write it with y. Y equals e to the x plus 2. I'm going to subtract the 2 to get rid of it. I don't need it there. So y minus 2 equals e to the x. I'm going to change this to exponential form. Look how carefully how it happens. The base is e. So I'm going to write a log with base e, which is natural log of y minus 2 equals x. X. Let me fix this. X. So notice how it happened, right? The base is e, here it is. The exponent of this one goes on this side, and the y minus 2 goes right here. If you want to switch this back to exponential, you would do e to the x equals y minus 2, right? So that's how you go backwards. And now switch the x with the y. First I move the x to the left side because I like it on the left side, although it makes no difference. Y equals ln of x minus 2, natural log of x minus 2. And I'm going to write it as f inverse instead of y, natural log of x minus 2. There it is.